Welcome to AI and Our Planet, Understanding Technology's Hidden Environmental Costs. In this module, we'll explore how new technologies, especially artificial intelligence, impact our environment and what we can do about it. This is a beginner's guide, so we'll keep things clear and easy to follow. In this module, you will learn about sustainability and its three pillars. We'll then uncover AI's hidden environmental costs, focusing on its impact on energy, water, and e-waste. You'll also discover how these harms don't just affect the planet but also people and economies, and we'll finish with some easy ways to use technology more responsibly. Let's start with the basics. What is sustainability? At its core, sustainability means meeting our needs today without making it harder for future generations to meet their own needs. It's about ensuring a good quality of life for everyone, now and in the future. We often talk about sustainability having three main pillars. First, the environmental pillar, which is about protecting our natural resources and ecosystems, things like clean air, water, and healthy forests. Second, the economic pillar, which focuses on having a strong economy that creates jobs and fosters innovation, but without using up all our resources. And third, the social pillar, which is all about ensuring fairness, equality, and well-being for all communities. Why do these matter? Because if one pillar is harmed, it impacts all the others. For example, damaging the environment can hurt our economy and the well-being of communities. So, what exactly is new technology? It's about recent innovations, new tools or processes designed to solve problems more efficiently or provide new capabilities. Artificial intelligence, or AI, is a perfect example. AI is a field dedicated to building computers that can perform tasks typically requiring human intelligence, like understanding language or analyzing vast amounts of data. You can think of AI as a powerful hammer, a versatile tool that can be applied to almost any data to make predictions or generate content. AI offers incredible benefits, but it also comes with significant, often hidden, environmental costs. These include massive energy consumption, a growing carbon footprint, extensive water usage, and increasing electronic waste. The challenge is that these impacts are often invisible to users, leading to increased demand and greater environmental strain. Let's explore these in more detail. So, the engine room for AI is vast networks of data centers. These facilities run 24/7, consuming huge amounts of electricity to power and cool their equipment. The scale is truly staggering. Data centers already use 1% to 2% of global electricity, and with AI's rapid growth, this could more than double by 2030, potentially reaching 945 terawatt-hours. That's like powering an entire country the size of Sweden or Germany. Therefore, AI alone is expected to drive a massive 160% increase in data center power demand. AI's energy demands come in two main phases. The training phase for large AI models is incredibly energy intensive. For example, training one AI model can produce around 283 tons of CO2, equivalent to 300 round-trip flights between New York and San Francisco. OpenAI's GPT-3 training alone consumed 1,287 megawatt-hours of electricity, enough to power about 120 US homes for a year. Then there's the usage phase. Each ChatGPT query uses 5 to 10 times more electricity than a simple web search. Billions of daily queries add up quickly, potentially leading to annual energy costs of nearly 30 billion kilowatt-hours if AI is widely integrated into services like search engines. The energy used by data centers, especially from fossil fuels, directly increases greenhouse gas emissions. We also see greenwashing, where some companies claim carbon neutrality with credits, but their actual emissions can be much higher. For example, Meta's 2022 data center operations reported 273 tons of CO2, but actual calculations showed over 3.8 million tons, a 19,000-fold increase. This massive power demand strains energy grids. Some utilities have even restarted retired coal plants to meet data center loads, undermining clean energy goals. Google's greenhouse gas emissions, for instance, increased by 48% in 2024 due to AI growth. Beyond energy, AI systems, particularly the data centers, also demand vast quantities of water for cooling. AI chips generate immense heat, requiring chilled water to prevent overheating. A medium-sized data center uses about 110 million gallons of water per year, similar to 1,000 households. Larger ones can use up to 5 million gallons daily. For AI specifically, each 100-word AI prompt uses roughly 1 bottle of water, and training GPT the 3rd of May have consumed 700,000 liters. Microsoft's water usage increased by 34% due to AI, and Google's by 20%. The increasing water demands of data centers are concerning, especially since many are in water-stressed regions like California, Arizona, Uruguay, and Spain. This often leads to protests from local communities worried about their water supply. For example, in Uruguay, communities protested new data facilities due to unsustainable water use during drought, and in Spain, demonstrators used the slogan, "Your cloud is drying my river." This highlights an issue of environmental justice, where AI's global demand disproportionately impacts local communities' access to vital freshwater. Next, let's talk about the e-waste avalanche. Electronic waste, or e-waste, is the world's fastest-growing waste problem. In 2022, 62 million tons were produced globally, but only 22.3% was recycled. AI accelerates this issue because its demands require constant hardware upgrades, leading to faster device obsolescence. This is often driven by planned obsolescence, where manufacturers design products with shorter lifespans, forcing frequent replacements. E-waste contains hazardous substances like lead, mercury, and arsenic, posing serious threats to health and the environment. Improper disposal, like dumping or open burning, releases toxic chemicals that contaminate air, soil, and water. A significant portion of e-waste is illegally shipped to developing countries that lack safe handling. Their workers, including children, are exposed to these contaminants, leading to severe health effects like cancers and neurological damage. AI's advanced capabilities rely on sophisticated hardware, which requires extracting a wide array of raw materials. High-performance AI components, like GPUs, need diverse, finite resources, including metals and chemicals. Rare earth elements, or REEs, are especially crucial for modern technology and AI chips. The rapid growth of AI is significantly increasing the global demand for these critical materials. The extraction of these raw materials through mining causes extensive environmental degradation. This includes enormous water usage. Producing 1 ton of lithium can consume 500,000 gallons of water, radioactive pollution from rare earth elements, deforestation and habitat destruction, and soil contamination from dust and chemicals. These environmental harms have a direct human cost, as communities near mining sites are exposed to contaminants, leading to serious health issues like respiratory diseases and neurological damage. This is a clear example of environmental injustice. Now, let's look beyond just the environmental damage. AI's impacts create a ripple effect across society, affecting both social fairness and economic stability. First, for social equity, AI's high water use can worsen local water shortages, leading to tensions in communities. Plus, pollution from e-waste and mining disproportionately affects vulnerable communities, leading to health problems and increasing existing inequalities. Next, consider the economic stability. The increased demand for critical materials can lead to higher costs and unstable supply chains. AI's massive energy demands strain our power grids, potentially raising energy costs for everyone. And the long-term health impacts from pollution mean higher healthcare costs for affected communities. Finally, AI can also encourage increased consumption through personalized marketing, leading to more global emissions from manufacturing. And if AI adoption is uneven, it can worsen digital divides, impacting access to opportunities and overall social fairness. So, how do we move towards a more sustainable AI future? It requires a multifaceted approach involving industry, technology, and policy. Many tech companies like Azure, AWS, and Google Cloud are committing to sustainability goals, such as becoming carbon negative by 2030 and using 100% renewable energy. Technological innovations include advanced cooling methods for data centers, like liquid cooling, and reusing waste heat for heating neighborhoods. From a policy standpoint, There's a growing need for standardized metrics and transparent reporting of AI's environmental footprint, with government oversight being crucial. So, as we conclude, you might be wondering, what's your role in all of this? While big, systemic changes from industry and policy are absolutely essential, your individual actions truly matter. You can become a more conscious tech user, and here's how. First, consider lowering your video resolution. When high definition isn't essential, simply opting for standard definition can significantly save energy. Next, think about extending the life of your devices. Instead of constantly upgrading, try repairing your existing gadgets or even buying used. This directly combats the e-waste problem. It's also crucial to recycle responsibly. Make sure your old electronics don't just end up in the trash. Take them to certified e-waste facilities where they can be properly processed. And finally, support sustainable companies. Choose tech providers that demonstrate a genuine commitment to powering their data centers with renewable energy and are transparent about their environmental impact. Ultimately, understanding the hidden costs of our digital habits is the crucial first step towards creating a more sustainable future for everyone. Now, let's test your knowledge with a short quiz based on what we've covered. There are 3 questions, and each one is multiple choice. Question 1. Why is sustainability important when discussing new technologies like AI? A. It helps reduce product prices. B. It ensures future generations can meet their needs. C. It makes AI faster and more efficient. D. It focuses only on environmental protection. The correct answer is B. Sustainability is about meeting today's needs without compromising the future, balancing environmental, social, and economic concerns. Question 2. What makes AI's environmental impact especially concerning? A. It only affects developing countries. B. It uses less energy than traditional software. C. Its high energy and water use are mostly invisible to users. D. Its benefits outweigh any environmental effects. The correct answer is C. AI's high energy and water use are mostly hidden from users, making it harder to recognize the strain it places on the environment. Question 3. What is one effective way you can reduce your personal tech footprint? A. Upgrade devices frequently. B. Avoid using the internet. C. Recycle electronics and extend device lifespan. D. Use AI tools for every task. The correct answer is C. Repairing, recycling, and keeping devices longer helps reduce e-waste and resource consumption. To wrap up, we've explored how artificial intelligence's rapid growth comes with significant, hidden environmental costs, including a massive thirst for power and water, an increase in e-waste, and the toll of mining for hardware. These challenges are all interconnected, impacting not only the planet, but also our economic and social well-being. While companies and governments are working on solutions, your role is crucial. By making conscious choices, you can make a real difference and help push for a more sustainable future for technology. Thank you.